All right, in this podcast, I'm going to show you another question where you have to use the binomial theorem to expand binomials of a high degree. So here's my binomial here. It says that I want to expand 3b minus 1 to the power of 4. Now, what makes this one a tricky one is that minus in the middle there, and we do have to address that in a moment here. So first thing you want to do is ask yourself, how many terms are there in this expansion? And remember, the number of terms is one more than the n value, which is the exponent. So 4 plus 1 gives you 5 terms. What row will this correspond to? So the row of Pascal's triangle, which the coefficients correspond to, is row 5. Okay, so keep that in mind when we calculate all these values. Now, here's my table method here. I want to start with the coefficients. So since we're looking at row 5 here, the first term is going to be 4 choose 0, which is just 1. 4 choose 1 is the next entry, which is 4. 4 choose 2, which is 6. 4 choose 3, which is 4, and finally 4 choose 4, which gives you exactly 1. All right, so that takes care of the coefficients. Let's go next to the x terms, which are the first terms. Okay, so the first term in this binomial is 3b. So I'm going to raise 3b to powers. And remember, x terms are descending in power, so they go down. It's going to start with a degree of 4. So 3b to the power 4, 3b to the power 3, 3b to the power of 2, 3b to the power of 1, and finally 3b to the power of 0. Next thing is the y term. So that's also the second term of the expansion, or the binomial. Now the second term, this is where that negative plays a role here. The second term is actually going to be a negative 1. So negative 1, we're going to raise it to a power of 0, because remember, our y terms are ascending in degrees. So negative 1, 0, negative 1 to the power of 1, negative 1 to the power of 2, negative 1 to the power of 3, and finally negative 1 to the power of 4. Now these are easy enough. I can actually evaluate them right now. Negative 1 to the power of 0 just gives you 1. This is negative 1. Negative 1 squared gives you positive 1. Negative 1 cubed gives you negative 1. And negative 1 to the power of 4 gives you positive 1. So you can see the pattern. The negatives are every second term here. All right, so finally, let's write out the terms of this expansion. So the first term is simply going to be 1 times 3b to the power of 4 times 1. So really, that is just 3b to the power of 4. Now remember, that exponent applies to both numbers here. So 3 to the power of 4 is going to give you 81, and we have b to the power of 4. So that's my first term done. Let's go to the next term here. 4 times 3b to the power of 3 times negative 1. So I'm just going to write this out here. 4 times 3b to the power of 3, negative 1 times negative 1. So it is going to be a negative term. So what we're going to have here is 4 times 3 cubed, which is going to, oh, and then times the negative 1, which is going to end up giving negative 108. And then our variable is just b cubed. All right, so let's go to the next one here. We have 6 times 3b squared times 1. So 6 times 3b all squared. Let's see what that simplifies to. I won't write the 1 there because we don't have to. So we're essentially taking 6 times 3 squared, which is 6 times 9. That gives you 54b squared. Next term here is 4 times 3b to the power 1 times negative 1. That's going to give you negative 4 3b. Okay, and that's going to simplify to negative 12b. Last term here, we have 1 times 3b to the power 0, which is just 1 times 1. So my last term is just going to be simply positive 1. Now, we could finally write this all out here. The expansion is going to look as follows here. So originally it was 3b minus 1 to the power of 4 is equal to, first term was 81b to the power of 4 minus 108b cubed plus 54b squared plus the constant, which is just 1.